I've been talking about generative AI for a while. Now, here is a very interesting conversation in generative AI. We have viruses that are specific to generative AI applications. Most of you would have heard of computer viruses, you would have heard of malicious attacks, worms. This is the first time that we have an AI worm, and we'll talk about what is worm and the difference with a virus, which is specifically targeting generative AI applications. This is a research paper. Let's take a deep dive in. So, in the past numerous years, companies have incorporated generative AI capabilities into new and existing applications, building RAG architectures essentially to bring their context and augment LLM's understanding of a space and kind of build a whole ecosystem that's essentially powered by Q&A and chats. The question that's being asked is, can attackers develop malwares to exploit the Gen AI component of an agent and launch attacks on the entire Gen AI ecosystem? As it turns out that this is true. We have Morris 2, which is the first worm designed to target Gen AI systems through the use of adversarial self-replicating prompts. Now, this is a very, very interesting thought itself, that the prompts itself are self-replicating. Let's see how this is happening. We'll try to take a deep dive into the paper as much as we can. I haven't implemented or practically tested it, but let's move forward. So there is a little bit of introduction. We'll fundamentally skip that and go over to the definition of a worm. So a computer worm is a type of malware which operates independently and it replicates. It spreads across a computer network most of the times without requiring any form of interactions. Viruses are usually programs that require a host. So you might have seen in the past that viruses would associate with exe files or word files, make them corrupt, or image files. Worms are different. They exploit vulnerabilities in operating system, and hence they are able to self-replicate. They can replicate across networks, propagate between host machines, essentially move around. So this is basically the definition of worm. Now, are all worms created for malicious intent? No. You can have worms which has a self-replicating nature, which is just doing nothing. It's pretty much just doing nothing. It's replicating itself. While it is a security, from a security lens, it's a bad behavior, but it's not causing you any harm. However, what is important is understanding this line. Worms can carry malicious payload, and they can have vipers, encryptions like ransomware, steal sensitive information, perform DDoS attacks, etc. etc. And they are essentially designed to exploit security weakness, and their ability to autonomously spread is really, really challenging to control their behavior. So that's what this worm definition is. Now, do we have attacks against Gen AI models? There's a little bit of uh, thought around, and then an initial discussion on the possibility of encountering Gen AI malware has been published very actively. Now, this is where the Morris 2 comes in, and Morris 2 targets Gen AI ecosystem and essentially interconnected networks consisting of Gen AI powered agents that interface with either Gen AI services to input to process the inputs sent to an agent and other Gen AI agents in the ecosystem. So basically they impact it in two ways: process the input sent to the agent and also impact other Gen AI applications within the ecosystem. Now it has Morris 2. Let's look at what type of worm Morris is. One moment, I think I need to plug. So a worm is a type of malware that replicates, spreads to new hosts, and performs a malicious activity. Now, the replication of Morris 2 is done by injecting an adversarial self-replicating prompt into the input processed by the Gen AI model, exploiting a certain layer of it. Now, this is essentially done by prompt injection techniques, and prompt injection is nothing new. People have been trying and playing around with it. screwing up LLMs for the past some time. LLMs have become better at it, but let's see what it is, what's happening. Then it has propagation behavior, like it propagates based on RAG, and it can also propagate based on application flow, steering based propagation. What is the malicious activity? It really depends on the application, the kind of permissions, the kind of code that's there. However, it's basically it can have a malicious property. Zero click property: input data is automatically sent to GenAI cloud and servers for inferences. The fact that input data was sent by an attacker and received by user application processed by GenAI model does not require the attacker to trick the user into clicking as an input. So basically, there's no clicking required here, and it can carry through itself via the prompts. And what is the idea of a self-replicating prompt? They are giving a definition. We'll skip that. So essentially, this is the kind of a process flow which I wanted to talk to you about. So this is an attacker. This is an app. There's a RAG. There's a core GenAI service. There's another app. There's a RAG. So this is basically the GenAI service, and let's see what the flow looks like. So the attacker sends a mail which has some sort of self-replicating prompt. It retrieves the relative correspondence, gets some context, generates an auto reply, goes to the LLM, and then comes back. And then what it is doing is it's actually finding a way to send an email to a different app, and you are essentially entering at the end of this conversation a CR2 state, which is a different RAG from an attacker. So it's basically reaching multiple RAG states. So this is the kind of a worm. And what's the threat model? The attacker aims to craft a message consisting of an stored in etc etc. I think this is okay to understand. So this they have talked about propagation. Let's move forward. Here's a little bit of code. There's a little bit of evaluation, and they have given prompts. I want to jump to the outputs and basically the error behavior that it is causing. Yeah, so this is also self-replicating prompt in an image. So this is an image, and they are doing self-replication here, which is like prompts, embeddings. We'll keep going down and keep look at. Yes, this is what I wanted to come to. All right. So what they have done is they have looked at Morris's ability, and through the self-propagating behavior, what they have realized is that it can autonomously get information around relative content from the RAG store back to the attacker. And the attacker can manipulate the application flow, forwarding to a different email ID and all of those setup. Now they have showed how they have worked and processed this. We'll skip that and let's go to the results. Yeah, there are limitations. They are also proposing some countermeasures. So all in all, basically what they are trying to showcase is they've taken some sort of a set test setup. They have taken some data, some prompts, deployed an LLM server, and trying to play with it to see if the behavior is simulated. And fundamentally, what they have found is that this worm has some sort of a self-replicating nature, propagating through RAG architectures or application interfaces, and has the ability to steal information from the RAG. So that's it from this. If you are building a LLM powered application, please try to reduce the risk by building in controls and countermeasures that can help you safeguard from these setups. Thank you. If you have liked the conversation, please subscribe. Bye bye.